Okay, this video is talking about stretches and shrinks. Basically, when you have a stretch or shrink, what's going to cause that effect is multiplication. Now, we're not going to look at multiplication with negative numbers because multiplying with the negative number is actually going to be a separate transformation. So we're just going to look at the number that's being multiplied. Some basic review is, keep in mind, if you multiply something by a fraction. So if I do, division, I guess, if you can think of it that way. But if I do 4 divided by 3, that is the same thing as doing 4 times 1/3. And that'll be key here in a minute when we talk about our stretch and shrinks. So let's take a look at some examples. Here's the rule. If you have a change happening on the outside of the equation, anything that happens on the outside, once again, is it's going to be a vertical change. So if you have multiplication happening outside the parent function, that's going to be a vertical change. If it's multiplication and that value is greater than 1, then it will be a vertical stretch. If this value here for C is between 0 and 1, then it will be a vertical shrink, which means it's going to get vertically is going to be squished. But the one that causes people the most problems are the horizontal changes. Horizontal changes are going to be happening inside the function. And horizontal, anytime you have some type of horizontal change, you're always going to do the opposite of what it tells you. So if the value being multiplied inside, and we'll call that C again, if that's greater than 1, it's actually going to be a horizontal shrink. And if that value is between 0 and 1, it's going to be a horizontal stretch. So basically, if it's going to be a horizontal stretch, what happens is this. If the normal graph is increasing at this rate, what's going to happen if it's between 0 and 1, it's actually going to take a lot longer for that graph to get up to that same y value. And so what happens is it's going to horizontally stretch the graph. So let's look at some examples. So the first thing we want to do is we're going to identify what the parent function is. Notice that we have an x squared. So my parent function is going to be a y equals x squared. Now, as far as the actual transformations, going from the original, which we will call f of x, can't do an x. You're going to do the transformations in order that you see them. Notice that the -4, if you're going to plug something in for x, you would have to do the -4 first, then take care of the square, but then you take care of this multiplying by 2 and then by adding 3. So what we have happening here is, in order, we have a horizontal shift going to the right because x is, you always do the opposite. Now the 2 here is happening outside the parent function, so that's going to be a vertical stretch. So then we would have a vertical stretch of 2. So vertically my graph is going to get taller. And then the last thing that's going to happen is I'm going to have a vertical shift going up 3. Now, as far as what the graph would look like, I'm going to pause here and draw the graph so you can kind of see what's happening. For the original parent function f of x, I'm going to draw that one in red. Now for the g of x, let's do that one in blue, and I'm going to pause it here. So f of x, or g of x would look something like this. Notice that we do have this shift to the right 4. That's what's happening here. We have the vertical stretch of 2, so my graph is much skinnier than what my original was, and I also shifted the graph up 3. So 1, 2, 3 there. Alright, now you try the next example, and I'm going to go ahead and pause it here, and then I'll put the answer up here in a second. So what you should have gotten for the next example, your parent function is the square root function, Notice that on B, you actually have a horizontal shrink of a third. So with horizontal shrinks, you always have to do the reciprocal of what is inside. It doesn't make sense for it to shrink by 3, because if something's going to be bigger than 1, it should be getting bigger, not smaller. And notice for the graph, f of x, here's my original square root, and when I do g of x, I have that horizontal stretch, which actually ends up pulling the graph and making it a little bit taller. And there you go.